This is the fourth tutorial for assignment A01 for architecture 5354. Um, and so next we've got the beginnings of establishing our site model inside Revit. We added the engineering drawing and then moved the project base point. We left the survey point there. Once again, you'll see that the survey point, it points to true north. Okay, and then of course the project points to what we call project north. So when we draw vertically now, we're going to be drawing on this axis, not on the true north axis. If we want to see if the project looks like in relationship to what true north is, it's extremely close, so it won't very much, but we can click out over off of an object and go back to the view or the floor plan view, and right here you'll see orientation. This is set to project north right now, so therefore the civil engineering walls here are vertical, or those lines are vertical. If we click on true north and apply that, then you'll notice everything was rotated to true north. So notice now this vertical line, this line for the survey point, which is true north, is actually pointing to north, and this line is 1.62 degrees off of true north. So if you want to know what the how far off. Okay, so just a little information about understanding. I'm going to go back to project north to do what we're going to do because I want to work at the angle we're going to be working at. And we're just going to add a topography. Now, what height should that initial topography be at? We can change and put in, if we had topo lines, we could use topo lines to create the topography. But in this case, the whole site condition here is pretty flat. And so normally what we would do is we would have a surveyor come in and they would survey and give us all some topo points so that we know what the elevation is on several of these things. Since we don't have that, I'm going to encourage you just to use Google Earth. And so I've opened up Google Earth here. You can see Google Earth Pro. Make sure you're not using Google Maps. Google Maps won't give you the information that you need. Google Earth Pro is now free. It's a free download. Go download it. It's a great tool for architecture, especially for preliminary stuff, and you don't need extreme accuracy. And then I'm going to type in here Texas Tech University, and it's got it already in there. And so we're going to zoom in, do the old Google Map zoom, right? And here we are. We can see our campus, and here's the key. There's the circle, Memorial Circle. Okay. And if we zoom in a little bit more, we can see here's our site. Google Maps does, unlike Google Maps, Google Earth allows you to turn on 3D version of the map, so we can see these as 3D objects within. We may or may not need that. In this case, we really don't need it a whole lot. So I'm going to go ahead and just turn that off. The next thing we're going to do is look at this vertically from straight down. Now, we can capture these maps and add them to Revit if we wanted to. I don't think we really need to do that, but if you wanted to do that, you could. I might have this open as I try to develop my site model so that I can check elevation heights, and you'll see in just a minute what I mean. So let's get started here. The middle button scrolls or zooms you in and out. Okay. If you hold down the button, okay, that rotates you. Okay, so if we want to go back to almost perpendicular or flat plan, we can hold down the middle button. I'm not sure how this works on Macs. I'm sure they have a solution for Mac. So if we zoom in here, and of course, if we hold down just the left button, then we can scroll over. So I'm going to get this kind of vertical here. Try to get this pretty much vertical. Okay, so that we can look straight down on this and get some elevations and some elevation heights. Sometimes that's easier to do from a 3D view. You can see the little people when the picture was taken. What I want you to do is, as I move my hand around, notice there's these lat and longs change. Okay, so we're changing the lat and long, of course, as we move here. And then you'll notice the elevation right here is changing. So if I zoom in here and actually I'm just going to go into, yeah, if I zoom in here and I go right over this piece of grass right in here, make sure you're not hitting any of the trees, you'll see that the elevation is 3225. And pretty much anywhere that I move here, even out here, it's 3225, closer to Boston Avenue and the street. It really, if I move 24, okay, so it's dropping off. We can see, and it probably drops off. Now, I got to remember, Google Maps is not really accurate. We're probably, we could be anywhere between a foot or more, a foot or 2 feet off on the elevations here. So there's probably more gradation, and it's only going to give us in the increments of a foot. So this might be, 32, 24.5, and this might be, 32, 20. 25, or something. So, but nonetheless, it'll give us some general idea. And so I'm going to assume that for the most part, this is pretty flat until we get to the street. And then you'll notice that the street, let's zoom in here. The street comes in at 3221, which is a 4-foot drop from where we are. I know that from the curb height, a conventional curb height is only 6 inches tall. So you'll see this is reached 3222 once again. So it's going from about 3221 right here to from 3225. So that's a 4-foot drop more or less across this. Let's go back here to the parking lot. We can see this is 3348. So once again, there's even more of a drop from, say, here on the middle of our site, which is 3225. No, there's about 3-foot drop from here to there. Okay, so we can make those adjustments if we want to our topo. But right now, what we're going to do is just put it in as a flat surface, and we're going to call that flat surface an elevation of 0. And then we'll work from that 3225 being, so right in here we're going to assume that this is relatively flat, and once again we can drop it, we can move it if we want to later, but I'm just going to put in a topo right now that is one flat surface. And to do that, I'm going to go into massing and site, and it's pretty simple actually, and then we're going to do topo surface. Okay. And then there's several tools here. Create from an import. In other words, if we were importing topo lines, and it'll show you, if we had a series of topo lines, we could bring those in. And since our GIS drawing that we brought in has no elevational data, then it wouldn't do us any good to use that. We can just do a simple surface, simplify a surface, or place a point, right? And so our default elevation is 0, 0, which is level 1. Okay, we're going to assume that this is absolute elevation. And then what I'm going to do is basically just create me a topo, a big flat sheet to work from, and then we'll work off of that. So to do that, I'm just going to put a point in, put another point in, another point in, and once I have 3 points now, I have a surface, right? And then I'm going to put another point in. And so now we have a topo surface. I'm going to set that, and there's our topo surface. If we go into an elevation, east elevation, or elevation, we're going to see there's that topography surface right there. Okay, on that same, notice the elevation is 0, 0. Okay. Level 2, we haven't set any levels or anything yet, so we'll do that later. But that topo line, if we go into 3D view, we don't have a 3D view set up. No, we don't. Let's go into views here, and 3D views, default to 3D view, and we'll add that. And we can see once again, there's our drawing. And then there's our topo surface that we created. Okay, so end of that step. Uh, we'll on to the next video.